Alright guys, so we've just established that all elements or all atoms within the world are looking to have full outer shells. That makes them stable, right? That gives them for those who are really looking at pursuing chemistry, that gives them the lowest energy state they can possibly have. And that makes them stable. It's like when you go to sleep, right? You're most stable in your bed. You're happy, you're chilled, that's where they want to be. The only elements, like we just said, that have that state at the current in their neutral state, their natural state is the noble gases. Everyone else doesn't have that. So what we're about to look at is how these elements try to achieve that in the real world and what that looks like. Okay, so we're going to start off with the alkyl metals. We're going to start off with sodium because we've been focusing on that a lot. Okay, so to do this, we're going to, I'm going to model sodium here, and we've also got sodium here. We can see that sodium, like all the alkyl metals, has one valence electron, right? Here he is. This is going to be my valence electron, this tennis ball, right? Now, if you were in the class with me, we'd be throwing tennis balls to each other and we'd be talking about this, but we're going to do the best we can with what we've got, right? So sodium has one valence electron. This is the guy that makes him super unstable. This is the guy that makes it fun to throw sodium into water. Because when he gets thrown into water, he's looking wherever he possibly can to give this guy away, right? Because really, sodium's got two options. If he wants to be like a rock star, if he wants his sodium here, if he wants to be like a rock star, which is neon, that's the closest one, he has to either gain 7 electrons to fill the outer shell, or lose 1, right? Now those are the two options. Which one do you think is easier? Gain 7, find 7 electrons from somewhere else, or just to lose 1? Lose 1, right? Really easy. Now he has to lose this, and so when he loses this electron, he can't just lose it, he can't just drop it, right? It's not just like you guys with your, whatever, your phone, your lunch, whatever, you can't just drop it and lose it. You've got to have somebody want to take it, all right? So I'm going to ask Mrs. Levy to come in front of the camera now, and I'm sure she wants to do this. Now, I'm putting her on the spot. She has no idea what I'm about to ask her to do. So we're just going to run with this and see how it goes, and if anything else, you guys got a bit of entertainment at home, right? So Mrs. Levy, welcome.
Hello.
Hello. So Mrs. Levy's going to be, we're going to model here the first type of bonding that we're going to talk about. And bonding is really about elements trying to achieve those neutral, natural states, those stable states of full outer shells, right? So I'm going to be sodium. I have 1 valence electron. I'm going to give Mrs. Levy an identity as well. I think I'm going to fluorine. All right, Mrs. Levy's going to be fluorine. All right, so that's number 9 right here. All right, now you guys should be able to do already. How many valence electrons does Mrs. Levy have? Do we know? All right, she's in group 7 or 17. And remember, the group number tells us how many valence electrons in there. It gives us a hint. So you have 7, right? Correct?
I have 7.
Cool. She's going to talk as well. All right. She has 7. Now, obviously, Mrs. Levy, I've seen her try to juggle balls before. Like on the way here, she's not the greatest. You know, it's not her gifting. So we're not going to make Mrs. Levy carry 7 balls. But we're going to hold up one hand because she's got 7 and she needs 8. All right. So she's a non-metal. She has 7. She needs 8. So how many more do you need?
1 more.
1 more, right? If she gets 1 more electron, she will be stable and happy because she will gain 1 more electron, have a full outer shell, and be happy and stable, right? Now I happen to have 1 electron, right, that I don't want. I'm sodium. I'm a metal on the other side. I have 1 electron I want to get rid of. Mrs. Levy has 1 spot that she wants to fill. I'm a metal. I like giving up electrons. Mrs. Levy's a non-metal. She likes gaining electrons, right? So we're going to do that. So Mrs. Levy's got 7 electrons. Now just remember that. But she's going to hold up her hand like this, like a high five. That's her spare spot. She wants 1 more electron, right, in that free spot. If we happen to run into each other in the real world, right, we could do that. I'm unstable, Mrs. Levy's unstable. We're not happy right now. I've got 1 extra electron, she's missing 1. If we run into each other, and that's what atoms have to do, right? They have to actually collide physically. We're social distancing right now, so pretend like we've collided. If we collide, what could happen? Well, Mrs. Levy goes, man, sweet. I got a free spot. I'm going to throw this. Are you going to be good with it? She's got a free spot. I've got 1 that I would like to get rid of. And we throw it, right? Boom, boom, shake the room. Okay. What does that mean happened? I am a sodium. I was a sodium atom. I had 1 extra electron in my shell. I've just given that away. It's gone. Look at my outer shell now. It's full. I'm happy, right? I'm stable. I'm feeling good. This is Levy over here. She had 7. We haven't drawn up fluorine. We're sort of on the spot here. But we haven't drawn up fluorine. She had 7. She's now got 8. She's gained an extra 1. So she is now stable as well. We're both happy, right? Here's the last thing I want you to get, right? When I lose an electron, I'm sodium, I've lost an electron. I now am no longer a neutral atom. I no longer have the same number of electrons and the same number of protons. Do I?
No.
Excellent. We're going into the old school. Anyway, it doesn't matter. I now have lost a negative charge. I've lost an electron. All right? I had it, I've lost it. I've now got an extra proton, more so than I have electrons. I have one extra proton. That gives me a positive charge. I'm now a sodium ion. ION. I'm a sodium ion, right? Mrs. Levy used to be a neutral fluorine atom. She used to have the same number of protons and electrons. But now she's taken one of mine. So she's got an extra electron, right? So that makes Mrs. Levy
Negative.
sweet. So I'm positive and Mrs. Levy's negative, right? I'm a positive sodium ion. She's a negative fluorine ion. What do positive and negative things do? You guys have, played with magnets before or whatever. Positive ends of magnets and negative ends of magnets stick together. Similar things happen between these atoms when they transfer electrons. So there's been a transfer of an electron. We now have charged particles, which are called ions. And now we actually stick together. Can we socially distance this somehow? Boom, boom. All right, sweet. That there is a bond, right? So we've just formed a bond. I'm happy, Mrs. Levy's happy, I've lost an electron I didn't want, she's gained one she didn't want, and now we've bonded, all right? We've formed an ionic bond. Ionic bonds are formed between ions. And ions are particles that have a charge, because they've lost or gained electrons. So this is an ionic bond. This has looked really awkward right now, right? So you guys are going to laugh at this, but that's cool. Hopefully you'll remember. Ionic bond is formed between metal and ion, but now we're happy, we're stable, we've bonded, and we're no longer dangerous, all right? We're going to leave it there for ionic bonding. Thank you. We can edit.